All right, as you can see this week, I am going to be talking a lot about weather fronts. We all know that as we move forward through the week, Nicola, we are preparing for the test that's going to be on Friday, right? So some of the things that we will see on the test on Friday, and to kind of go backwards on the slides here. Obviously, we might see some of the air masses around the globe, correct? And we remember how to put those two things together if you paid attention in class and if you did your work on that Wednesday. We have continental air masses and maritime air masses, and depending on where they are, it depends on how much moisture is in the air. Then we had Arctic, polar, and tropic, and that told you the temperature of the air, and you put those two things together, and it kind of tells you what type of air you have. And we're not going to sit here and go over all of that today, but those are things that we're going to have on there as well. If we look back, we learned about the different winds around the globe, right? And I know the doldrums are important, and some of you wrote about that on Friday when we did our project on Ellen MacArthur. And it's important to understand where they are, that they're near the equator. It's important to understand that because it's so hot there that the hot air rises a lot, and there's not a lot of wind. And that's pretty much about it, right? If we were going to pick one that was the most important, trade winds are important. They will probably show up on a test or something, but I think if we were going to put one on there, it would probably be the prevailing westerlies are the most important, Maya. We're going to get the most questions from that. And the reason why, Tori, is because that's what brings the weather across the United States. I'm happy that the prevailing westerlies took Ellen MacArthur home. That's not going to be on the test. What moves weather across the United States? The prevailing westerlies, Ruby, it will most definitely be on the test. I'm certain that those questions will be on the test. So the different global winds are important. As we look back, we learned about mountain breezes and valley breezes. As I mentioned, I'll be lucky to find lots of questions about mountain breezes and valley breezes, but there are some that are on there. If we were to think about it, probably the most important of the breezes were the land breeze and the sea breeze. And Braden, I think we learned on Friday when we took the quiz and we went over the data in all three classes, the way that they write the questions for sea breeze and land breeze it is not which breeze blows from the sea. You know the question is not that easy, is it? That question was very long, and it was like during the day, the land heats up faster than the ocean. The air above the land rises. And we all learned, I hope on that day, especially those of us that missed it, that it's worth taking the time to draw that picture out for land breeze and for sea breeze on your paper so that you can see it and visualize what the words are saying as opposed to trying to read that long paragraph and visualizing it, in my opinion. Right? Because that was the lowest scored question on all of the quizzes. And I think we learned something there. So sea breeze and land breeze will be on there. Again, this is kind of going back through the polar easters and trade winds. We'll skip through some of this here. How wind forms. High pressure and low pressure. Will that show up on our test? Most definitely. Most definitely. How wind moves from high pressure to low pressure will most definitely be on the test. I'm sure the definition of wind will be on there somewhere. Barometers will be on there as we look at this picture here. And this is what we started the whole unit off with, and I think it started to help make sense to a lot of people. Convection cells, the way heat rises and cold sinks. And it causes that circulation, that circular pattern of air movement. And so updrafts and downdrafts and convection cells will most definitely be on there as well. I'm sure humidity will make its way on there. With that being said, I'm certain, Carter, that the water cycle is going to make its way on there. And you're probably sitting there thinking, holy cow, this is going to be a pretty massive test, right? Here's the crazy thing, kids. We're not even done with weather yet. Like, we've barely touched the tip of the iceberg in weather. We have so much more stuff to cover as we get into weather. So don't think that all of a sudden everything's over. Understanding air temperature is going to be very important, is it? I mean, it is. It's extremely important. And this is what leads us into pretty much what we're doing today with fronts. So weather fronts. I would go back and change this, but I think that would end up changing the codes for people, and I don't want to do that. When I look here, all of a sudden, oh dear, something on my screen requires Flash Player. And if you all have learned, and I'm super disappointed that Flash Player doesn't work anymore, because one of my favorite things in the entire world was getting ready to come up soon was Save Fred. And Save Fred apparently is Flash, and I can't play that anymore. And I'm really bummed about that. I've got to find another way for us to play that. But this was a site here that helped me animate for you warm fronts, cold fronts, occluded fronts, and stationary fronts, which is kind of a bummer that it's not on there. But I found another one last night, so it'll be all right. So we won't have to worry too much about this screen. So if you're looking through, I've got to go back in. Now, what I did was, I think I did. Maybe I didn't. Maybe I could go do that now. Let's see here. Copy that. And we'll just hit an edit button on this. Edit. Add a link. And we'll add the link. There you go. So, if you need it, right there it is. Weather fronts are down there. It's going to be in the Google Classroom for this week. It won't be on the Nearpod slides, which is kind of a bummer. But I'll get it in there some way, somehow. I'll figure that out. So, if you look here, it looks like we have 4 main fronts, right? Cold front, warm front, occluded front, and stationary front. 4 main fronts. Cold front, warm front, occluded front, and stationary fronts are our 4 main fronts. And I'm going to get into each of those, and I'm going to get into why they have these specific designs and colors as they move along. You're going to need to know those symbols. Those actually show up on EOGs and tests and things as well. We're going to learn how these move, like what direction they move in. We're going to learn what type of weather they bring as we move along with our weather fronts. I'm going to wait on that. If you're at home, you can go back and watch this video. We'll come back and watch this video together as soon as we finish this little mini lesson for everybody at home. Warm fronts. Warm fronts. A warm front is a boundary between 2 air masses. Obviously, one of those air masses is warm. A warm front is the front part of the warm air mass. Does that make sense? If I have a big ball of like warm air, the front of it is the warm front. And it's moving into an area of colder air. You'll have warmer air running into colder air. Now, here's what happens when you have a warm front. You're going to get these symbols on a weather map. This little like red line with the little like red humps on it, the little red bumps. That is, you need to know how to draw that. That is a warm front. Okay. The direction that those little bumps are pointing, you can see that they're kind of pointing this way, tells you the direction that the warm front is moving. Tells you the direction that that warm front is moving. Now, we all know that if there's warm air moving somewhere, there's a chance of moisture being in that air, right? It could be warm, dry air because we learned about that, but it could be warm, moist air. And that's going to depend on, are just some clouds going to form, or is it going to be like a lot of rain that forms when you have a warm front? Hopefully that next slide is going to describe that. When you have a warm front moving through, I'm going to actually pause. When you have a warm front moving through, obviously you have warm air coming in and bumping into cold air. Can you see that on the screen? Now here's the cool part that I get to like kind of drag this across. I think I get the... Do you notice how the warm air goes up and over the cold air? Is there anybody in here surprised that the warm air goes up? No, none of us are surprised that the warm air goes up and over the cold air, because cold air generally sinks down because it's more dense. The hot air goes up because it's not. Now watch what happens as this warm air goes up. Clouds start to form. Now, if there's a lot of moisture, you're going to have rain. If there's not a lot of moisture, you might just have some cloudy days. Can you see how that works? You can see here like it has it that it's raining when the warm front moves in. So warm air comes in, it hits that cold air, that cold air mass, and it moves up and over top of it. And when it does, it can bring precipitation, which, if I'm not mistaken, was kind of what we were saying here. A warm front indicates that a warm air mass is moving in the direction that this little red thing is pointing. When the warm front moves in, if it bumps into a cold air mass, it moves up and over top of it. Up and over top of it. And when that happens, you can have clouds and precipitation. So again, think about, like, I don't know why this says type up here, but when you have a warm front, we're assuming that it has moisture in it. Again, it could have like little moisture. And that warm air is going to rise up above the cold air mass that it bumps into. Because that's what's happening. Air masses are hitting each other. Okay, cold front, warm front, there's a collision of two air masses. We're assuming this one has moisture in it, and that goes up. Now, if warm, moist air is going up, we know that it's going to eventually, from evaporation to condensation to precipitation. But as Malachi and I were talking, if there's not a lot of moisture, not a ton, it could just be stratus clouds that are formed. The thing that you need to know with warm front is showers that might last a day or two. These are not your super strong like showers. These are just showers that might last a day or two. All right, let's move into cold fronts. Now, obviously, if the warm front is the front part of a warm air mass, then is anybody shocked that a cold front is the front part of a cold air mass? No, we're not really surprised about that. Now, this is where cold air moves in. Now, do you think it would go up and over the warm air? No. Is that typically what cold air does? No, cold air sinks down below, and it sinks up under the warm air that's already there. Now, if I'm shoving a bunch of warm air up into the air pretty quickly, what's it going to do? If it's got a lot of moisture, it's going to go from evaporation to condensation to precipitation, right? Cold fronts, if I go back, move a lot faster than warm fronts, and they shove all this warm air up pretty quickly. Do you see how fast that warm air is going up into the air? Now, I want you to notice something. What kind of clouds? I'm building these super tall clouds all of a sudden. What am I building? When you have a cold front, you can build cumulonimbus clouds, which is going to bring a lot stronger weather than a warm front brings. Cold fronts have the ability to bring thunderstorms, and depending on how quickly they're moving and how hot and moist the warm front it's bashing into is, it can cause extremely severe weather. So again, cold front looks very similar to what we were drawing with the warm front, except instead of little like bumps, it's like these blue triangles, these teeth. And I'm not going to go back and color those in right now due to time on here. But a cold front has this thin blue line with teeth pointing towards the way it's moving. So it's moving this way. A cold front is moving a lot faster than warm fronts move. Warm fronts are a little bit slower, and because it's moving so quickly, it pushes that warm, moist air that it bumps into and crashes into up into the air very quickly, and this can cause thunderstorms. And we saw that in the interactive website, right? As that cold air came in, it sinks down up under there very, very quickly, pushes things up in the air, and that causes, obviously, at sometimes some pretty severe weather. Warm front, cold front, I see both of those there, right? If you look at the picture, they're both there, except in this situation, Carter, no one is moving the other one out of the way. In a warm front, it kind of starts pushing the other cold air out of the way as it goes up and over top of it. In a cold front, it goes up under the warm front and kind of pushes it out of the way. In this one, the cold air and the warm air in the middle keep kind of bumping into each other. But they really don't do anything. They don't move a lot. They are stationary. They are stationary. It's one of those things where like the warm and the cold are kind of pushing each other back and forth just a little bit. And you get something called a stationary front. Now, if you have a stationary front, you're not going to be surprised